Hi sir, this is Ren Cyruz at Batungbakal from BSc 1E, and this is my video presentation or discussion in our subject Physics for Engineers. In this video, pag-uusapan naman po natin yung motion at constant angular acceleration. But before we go on to our example, I will first read the definition and show you the formulas for this one. So, motion at constant angular acceleration. The rotational equations for constant angular acceleration are just analogous to the transitional mechanics with the same derivations. So we have the formula for transitional motion at constant acceleration and the formula for rotational motion at constant angular acceleration. Now that we already know the definition and the formulas for our topic, we'll now go on to our example. In this example, a disc initially at 3.5 rods make 3 complete turns before coming to a stop. A. Calculate its angular acceleration, and B. Calculate the time thus take to come to a stop. So, lagay lang natin. So, sabi dito, for letter A, given na yung ating angular position and yung theta. So, in revolution, so we have theta is equals to 3RA. So, ngayon, yung 3 revolutions natin, i-convert natin into pi radians. So, theta is equals to 3 revolutions, 2 pi theta, 2 pi radians, sorry, is equals to 1 revolution. So, makakancel na natin yung ating revolution, and by calculating, we have the theta is equals to 6 pi radians. And to calculate for the angular acceleration, gagamitin natin yung fifth equation, which is ito. Ang ating final angular velocity squared is equals to initial angular velocity squared plus 2 angular acceleration theta. So, pag inayos natin siya, ito na siya. Since ang hinahanap na natin ay angular acceleration, so angular acceleration is equals to final angular velocity squared plus initial angular velocity squared over 2 theta. So, and by substituting, angular acceleration is equals to yung ating final angular velocity ay 0. Since sabi nga sa problem, yung problem natin coming to a stop. So 0 na siya with a initial velocity of 3.5 radians per second. So 0 minus ang ating initial angular velocity, which is 3.5 radians per second, quantity squared over ang ating 2 and yung theta natin, which is yung ito 6 pi radians, and by calculating ang ating angular acceleration ay negative 0.3249 radians per second squared. For letter B, calculate the time thus take to a stop. So, gagamitin natin yung first equation, which is, so letter B, lagyan na natin ito na A. So, letter B is equal, ito yung gagamitin natin na yung first equation, which is final angular velocity plus our angular acceleration, and time. So since sinasolve natin yung time, we have time is equals to our final angular velocity minus our initial angular velocity over the angular acceleration. So, by substitute the formula, time is equals to our 0, yung ating final angular velocity ay 0. Napaliwanag ko yung kanina po. So, and then yung ating initial angular velocity is 3.5 radians per second squared over ang ating nakuha po kaninang angular acceleration, which is negative 0.3249 radians per second squared. And by calculating, ang time po natin ay 10.7735 seconds. And with that po, sir, nakuha na po natin yung ating answer for this question. With that po, sir, thank you po for watching. Keep safe and God bless.